In this lesson, we'll take a look at reading from an SQLite database in the Corona SDK. Here, I've scripted a very simple application that reads from a database taken from the California Department of Education. The database has one table with over 16,000 school entries. The application is written such that upon load, the contents of the database are stored into a local table, and when the red button is pressed, a random school name and associated county are fed to the output label. Let's get started. So that we can more clearly see our data, I'm using the SQLite Manager for Firefox. Even though it says here not available for Firefox 3.6.3, I'm using an earlier version so that we can still see the data. I'll open the window, and the database consists of a single table called California Public Schools, but California with a CA. And there are 16,922 records. Now this second table is a table created by SQLite. There's no need to worry about it. It's a table that stores the history of the table creation in SQLite. At least that's what I can figure out that it does. As we look at the data, there are lots of different columns, and this was populated from a comma-separated values list. And the only column that will not appear in the Corona SDK is this first one called row ID. That's just for our own reference here, but we're going to craft a way to set IDs for the entries in the database. Let's get started. We'll take a look at the project directory first. And I've got the typical files that I'll have for a project, including the build.settings and the config.lua. Now the config.lua is set with a height and width of iPad proportions, so just something to keep in mind. The main.lua is empty except for two declarations that I use in all of my tutorials and all of my projects. And these are global constants that store the height and the width of the display. So we'll get started now with the database by first typing out the line that we'll call the database library. So local SQLite equals require, open and close your parentheses, and then within there, open a string SQLite 3 and close the string. Now, if we were to render the project right now, nothing would happen. We need a lot more information. So let's create now another line, local path equals, and this is system.path for file, open and close parentheses, and within the parentheses we'll type db.sqlite. Now you can probably guess what this is doing just by looking at the code and looking at the dot syntax. So we're telling the system that we want to load the db.sqlite file using this path for file method. And so the next argument will tell the system where it is. So it's in system.resource directory. And notice all of the capitals. Okay, so one thing that's really important is that this tutorial is just on accessing databases, so read only. If you were to try to write to a database in the resource directory, and we're talking about iOS here, your application would actually crash because the resource directory is read-only. I'll go over in another movie how to write to a database. So this is just read-only. Okay, let's type another line, local db equals SQLite.open, open and close parentheses, path within. So now we're telling the SQLite library to use its open method on path, and path is representative of the database and its location on the system. Two other things we will enter before we get started with the meat of the code. One is to create a runtime event listener that listens for the application closing. Because if the user happens to close the application, let's say they're in the middle of using it and they want to check their email, we want to make sure we close the database so no corruption happens. So we'll type runtime add event listener, open and close parentheses. And the first argument will be system. We're listening for a system event. And then we will type on system event. And this is really any method that you would like to call. We're just going to create one called onSystemEvent. above this line, and it's important that it's above, local function on system event, open and close parentheses, and we'll put an E in there. That's representative of our event, end. Now within this function, if, open and close parentheses, then end. Now within the if parentheses, e.type double equals application exit. So if we get the application exit event, if the runtime hears that, then what we want to do is within these the condition db::close. So close the database. Save it, head to the simulator. Will anything happen? No. And we don't have any errors either, so that's good. Now we can get to the heart of the code. For convenience, I've already created two methods that I'll paste into the document and explain. The first is a method that will help us create labels. So it's very straightforward. We're creating a function called label that accepts params. Params is an object, and it's simply a text object whereby the text property of the params object sets the text, and then the size property sets the size of the text. The rest of this is pretty self-explanatory. Take a moment to pause the movie, look at it. We've done this lots in our tutorial series. The next method is a bit more complex. It creates the big red button in the center of the application. So I'll copy and paste that. Okay, so this method here, big button, is actually a group, and a group that consists of two or actually three different parameters. One is an image of a disk, so we can see that here, g.image. Another is a text object, and then a third is a caption, press me. Now, in case you're wondering why I didn't just create these three different objects with different names, and why I instead used a dot syntax to essentially load them into the group table, is because it'll help us access the objects a bit easier outside of the constructor. So that way, when I assign a variable to big button upon creation, I can use that variable name plus .img or .txt or .caption to access those objects. Anyhow, it's a bit more sophisticated approach to creating an object and then accessing its children. Do notice, however, that though these are within the table G, they still need to be inserted into G, which is odd, especially if you come from an ActionScript background where there's already an implied insertion with children.syntax and their parents. Okay, so now what I'll do is at the bottom of the script, I'll create a function called go, local function go, open and close parentheses, end. Then I'll type go, open and close parentheses. So this is similar to init or new. This is the function that's going to run once the application has loaded. Now we'll very quickly create three objects, and we'll do that within the go method because that is the method that's going to execute immediately. And in case you're missing a little bit off screen, it's just some of the size declarations for the text. And you can see here we're using the label object and the big button object and another label object. We'll save it and head to the simulator, and this is what we've created. So a label, the large button, and then the output. So now we get to the heart of the tutorial, which is traversing the rows within the SQLite database. Okay, so what we're going to do is before we create these objects, we want to read the database. So let's create a method called return all rows. So now we will go just above the local function label and type local function return all rows. Okay, so within this particular function, we'll type the following. Local r equals, open and close the curly braces, so we are creating a table, and we're going to return this table. The idea will be that we will read from the database and store its contents into a table that we can access So that way we don't have to continually read from the database. It's really a matter of preference, what you choose to do. I typically don't deal with databases that have 16,000 plus entries. I just was looking for something online. That's what I found. I wonder if that's really the best thing to do, create a table with that much data locally, but it doesn't seem to hurt performance. Okay, so now we'll create a local index, local I equals 1, and this index is going to increment as we traverse the rows in the table. And now we'll get down to business. For row in db colon n rows, open and close parentheses, do and end. Now there's one piece of data that's missing, which is the SQL statement. Let's go ahead and create that above the for loop. Local SQL equals. Now this is where you would put your SQL statement. Select, that's in caps, star from, then the name of the table. Now let's head to Firefox so we can be sure what we're selecting here. So in Firefox, in the SQLite Manager, we want this name right here. We're basically saying select all entries from the CA Public Schools table. Okay, so that's CA Public, that's with a capital P, Schools. Okay, so select all from public schools, and then we're going to put in the parentheses of db and rows SQL. Okay, now within this for loop, we are going to grab the county column and the school column. Take again a look at our database. So there's the county column here and the school column. Now you'll notice that in the school column, there are some empty entries. So we need to write a condition that basically tests for empty entries and does something, because if we don't do that, we are going to get an error. So go back to the code and now type local C equals row.county. So we'll break it down here for row in db and rows. This variable is equal to the row result that is being fed back from the database. So we can access a column, you notice here it's capital C county, by typing row.column name. So here it's county. And we're assigning that to a local variable C. Don't have to, but we choose to. Local S equals row.school. Notice the capital S. Now, type a condition to check for school having a value. If, then end. If row dot school, actually let's do it this way. If S double equals nil, then S equals no name given. Okay, so just in case the result here of the school field in that row is nil, we'll just assign a string called no name given. Excellent. Now let's go ahead and print something. Print, open and close parentheses. So county colon space, then concatenate C, and concatenate another string, school colon space, and concatenate S. Save it. And the last thing we want to do is we actually want to assign the data to our local table that we are returning. So our I, remember I is an index here that we are using, equals, open and close your curly brackets, county equals C, school equals S. Finally, you got to remember to do this last part. You need to increment I. I equals I plus 1. Excellent. Let's select the title here of this method and then paste it as the first line to execute within the go method. We'll need the terminal since we are printing to it. And here it is. Clear it out and let's head to the simulator and refresh it. And you saw all those values, all 16,000 plus of them, have now been printed. The performance is pretty fast, but I'm on a Mac Pro Tower, so it's going to be a bit slower on the device. Again, when you're dealing with this many entries, just be cautious. Okay, so now what we need to do is we need to script the interactivity of the big red button. So let's go down to the go function, and right after the output line, let's code the following. Red button, colon, add event listener, open and close parentheses, touch as the first argument, and red button as the second. So the red button will handle its own event. Above this line, function red button, colon, touch, open and close a parentheses with an E in the middle, and end. Now within the parentheses, if, then, end. If E dot phase double equals ended as a string, or E dot phase double equals canceled. So we're looking for either the ended phase of the touch or the canceled phase. Then we'll pull a random entry from the table that has row results. Okay, so local m equals math.random, open and close parentheses. First argument is 1, second argument is $rows. Okay, one thing we've got to do now that I actually realized this is we've got to go back to return all rows. Local rows equals return all rows. That's important because remember that return all rows is actually returning an object that has all of the rows, and we need to assign that to a variable called rows. If we didn't do that, this would fail miserably at this point when we would press the button. So m is creating a random number between 1 and the length of the rows table. And now we'll type output.text equals, open a string and close a string. Notice that output here is a label. Okay. Now within the string, output.text equals entry # space, close the string, and concatenate m, concatenate colon space, and the string, concatenate rows, m dot school. So notice the dot syntax here. We're taking the index that was created here, and we're loading that portion of the rows object and the school property of that portion of the rows object. Dot dot now space in and concatenate rows m dot county dot dot and start a string space county and period within the string. Okay, that's all of our code. Let's go to the simulator and test it out. Okay, we'll reload it, and now if I press the red button, there you can see entry 1, and somehow it actually gave us the first entry, no name given, entry number 2226, Donald L. Ream Elementary in Contra Costa. And if I just keep pressing this button, I'll get random entries. So it's pretty easy to read from a database. First thing you need to do is you need to call the SQLite library and assign that to a variable. Next, you need to tell the system where your database is. And here it's in the resource directory, and since we're using a read-only database, it doesn't matter that it's in the resource directory, as we're not going to write to it. Then you need to create a DB object that is essentially telling the system to open that database. Then you need to create a system event that's listening for the application exit event, so that if the application exits, let's say the user wants to close your application, check their email, or use Facebook or whatever, it will close the database. Okay. After all of this business is done here, then we created some simple display objects. Here a label, a button, etc. But the most important thing is that we created a method called return all rows. Now what return all rows did was it created a table that would be returned. And we traversed the database using this SQL statement. And we stored the contents of the database, at least certain contents, into the rows object. And that rows object was then returned, and it was stored in this local variable rows. Once it was stored in rows, we could use that throughout our project. So here within the handler for red button, we see that we're able to get the length of rows. That's because it's filled with all the contents of the table. And we can access portions of rows by using rows, bracket, and then the index and the properties. So .school returns the school property. And up here, within the return all rows method, the critical line is this one, so that when we're traversing all of the rows of the table, we're storing the values within the table that is returned. And here we are returning the property and value.
For a small fee, you can download the project files for this tutorial at cheetomoskeeto.com.